right, we are flying in an airplane. Actually, we are flying an airplane, and air traffic control has just told us that we need to make a 3-degree descent. We need to start descending at a 3-degree descent to the ground so that we hit the runway at the airport. Our instruments in our airplane are telling us that we're 1.5 miles in the air. Air traffic control is telling us we need to make a 3-degree descent. With that information, we need to figure out how far away from the runway we are. As I advised you, drawing a picture is never a bad idea. So if I drew my picture, this is my airplane that I'm flying. Okay, and I'm heading, let's see, this would be towards the door, so let's just call that east. Here's my runway, so this is what I want to hit, and I want to hit about right there because I want to be able to hit the brakes before I fall off the runway, correct? Right? And so I want to make a 3-degree descent so that I hit my mark. And this is going to be 3 degrees. And I now want to figure out how far I am from the runway. Yes, no? Yes, no? Okay. So this is my right angle because with trigonometry you need a right angle somewhere. Okay, you guys cool so far? Who drew this picture? No, a couple of you? What did the rest of you draw? Did anybody draw, just for kicks and giggles here, let's try this out. Did anybody draw this picture? Here's my airplane. You have to bear with me for a second. Here's my runway. I want to hit this point. I know that I need to descend at 3 degrees. And I want to figure out how far I am from the runway, knowing that I'm 1.5 miles in the air. Okay, so I'm looking for x, just like up here, I'm looking for x. And by the way, on this one, this is not the distance to the runway from the airplane, is it? This is the distance. It's got to be that straight line. Okay, so over here, on my other picture, is this the distance to the runway? Or is this the distance to the runway? Which one? Bottom one or the hypotenuse? The bottom one. The hypotenuse is going to be a bit greater. Okay, so if you're doing this one, if you're using this one, is this a 3-degree angle? Is that going to be your 3-degree angle? It's going to be an 87-degree angle, isn't it? Just depends on which way you look at it. So we'll come back to that one in a second. Let's solve here. Let's solve for, I'm going to get rid of part of this runway. Let's go up and solve for our 3-degree angle with the airplane, and just knowing that our distance is going to be at the top here. So it's not technically going to be the ground, but it's going to be the same as on the ground. How would you solve for x? What is our distance? Anybody got an idea? No one's got an idea. SOHCAHTOA. SOHCAHTOA. 1, 2 people have an idea. I know that I have to use 3 degrees because that's all I got. And I know that I have to use 1.5 because that's all I got. And I know I have to solve for x. So somehow I need to have enough information to solve for that x. 2, 3 people. Laura Bemo, what do you got? Tangent of 30?
Of 3.
Okay, tangent of 3.
Is equal to 1.
The tangent of 3 is equal to, so TOA, right?
Yeah.
So tangent is opposite.
Over
What?
adjacent.
Opposite over adjacent. All right, so let's go tangent of 3 equals opposite, which is 1.5, over adjacent, which is x. Okay. Now what?
So it's 1.5 is equal to the tangent of 30 times
The tangent of 3 times x, okay? What are you doing next?
divided by the tangent of 30.
Multiply by or divide by the tangent of 3.
Yeah.
And we can solve now because this cancels out with this. What is 1.5 divided by the tangent of 3?
28.62
20. That's rounded to the nearest hundredth.
Yeah.
We're 28.62 miles from the runway. Make sense?
Yes.
Okay. Just box that. And now just for kicks and giggles here. let's see if you did it this way. So if you were going to use x as the actual ground, even though it really doesn't matter if you use it as the non-actual ground because it's going to be the same distance. They're parallel. It's going to be the same distance no matter if you're going from the airplane through the sky and then down to the runway, or from the airplane down to the ground and then over to the runway, however you want to do it. How would you solve this one? Catherine? What? SOHCAHTOA. What do you want to use?
Tangent.
Oh, you want to use tangent again? Tangent of what?
87.
So let's do tangent of 87 equals.
X over Y.
So x would be your opposite, and 1.5 would be your adjacent. Solve, Catherine.
Plus multiply tan of 87.
Oh, you want to do that first? Okay. I was going to do x first, but you can do that. Tan of 87
Times 1.5.
equals,
X.
and what do you get?
28 times
28 points.
62.
Same?
Yeah.
Woohoo! Got it. Makes sense. The tricky part on this one is figuring out how to draw. I think it's the pictures, the tricky part. I know that you guys can figure out the airplane. And I know that you can figure out the runway. Draw a little line there. But where's the 3-degree angle and where's your 87-degree angle? You could use the 87-degree angle. Because ultimately you're going to come up with a 90-degree angle if you put them together anyhow. So, yes, no, maybe so. Questions, comments, quandaries, quibbles, quotes, queries? Do you think this is pretty cool stuff, or yes, no? Is anybody alive out there? Hello? I'm gonna tell you right now, most adults, actually I'd be willing to bet 98%, 99% of all the adults in this building right now would have no clue what this means. So you are getting into some pretty heavy things here. Matter of fact, I bet you go home and ask your parents for help on some of these, and they're not going to be able to help you. This is getting into that point where parents are kind of saying, oh yeah, I did this, but I don't remember it anymore. So I think it's pretty cool that you're doing that as a 6th grader.